Good evening. This is a short video on bearings and a little extra at the end. The diagram is a scale drawing of an island with the villages Acton and Belleville indicated. 1 centimeter, for every 1 centimeter on the map is actually 15 kilometers in the real world. Calculate the shortest distance in kilometers between Acton and Belleville. Now, what did I do? I measured it, and it's actually 11.3 centimeters. Now I have to convert that into kilometers. So what do I know the conversion factor is? 1 centimeter is equal to 15 kilometers. See? And then I put 11.3 centimeters is, I don't know, how much ever kilometers. Centimeters cancel for centimeters. I cross multiply, I get 1 times x is equal to 15 kilometers times 11.3, 169.5 kilometers. That is the distance. Now, part B, write down the bearing of Belleville from Acton. Okay, so from Acton. So from Acton, I measured with my protractor, I came up with 106. So that's, and please remember bearings are always measured from the north line clockwise and written as a 3-digit number. So this is my bearing, 106 degrees. See? Now it says here, write down the bearing of Acton from Belleville. So what do we know? If this is 106, these are co-interior angles. That means that these two angles must add up to 180. That means this angle is 84. How do I find this bearing? Remember, the bearing is measured from the north line clockwise. All right. So I keep going. So I subtract 84 from 360, and then put 276. So the bearing is 276 degrees. Elan's surveying crew drove east a distance of 96 kilometers from Acton. Calculate the length east from Acton that this would be on the scale drawing. So I have to change 96 kilometers to centimeters. Once again, I use the same scale. 1 centimeter is to 15 kilometers as x. I don't know how much centimeters is equal to 96 kilometers. Kilometers cancel the kilometers. I cross multiply, I get 96 times 1 is equal to 15 times x. Divide by 15 and I get 6.5 centimeters. cm. I didn't get the cm on there, okay? Let's flip over to the next one real quickly. Okay, massive cell. Wow. Okay. Okay, back again. A ship S is 10.5 kilometers from P. Actually, let's just avoid reading the question, eating up time. I can find the distance PQ. PQ is where? From P to Q is up here. You see that? Now, what do I have? I have this triangle here, where the hypotenuse is 10.5, and one of the sides, I'm going to call this for now the adjacent. Now listen, you only have sides, so we can use Pythagoras. So what I end up is, I'm redrawing the diagram. I know I have an extra thing in here with theta, right? So I get only one formula I gave you, 10.5 squared is equal to 8.4 squared plus x squared. Bringing the 8.4 over, I get x squared is equal to 10.5 minus 8.4. Taking the square root of this, I get that the length PQ, which I call x, is going to be equal to 6.3 kilometers. Bam. See that? The angle PSQ. PSQ is going to be right here. Right here. How do I find that? So I redraw the diagram, and I'm going to call that theta. What do I have? I have the adjacent, and I have the hypotenuse. I'm going to use cosine. So I set it up like this. Cosine, the unknown angle, is equal to 8.4 over 10.5. Then the unknown angle is the inverse cosine or cosine inverse of 8.4 divided by 10.5, and it came up with 36.87 degrees. Okay, you see that? Bam. The bearing of P from S. P from S. Okay? So from S, I'm going all the way around to P. Now, see, you always start at the north line 0, 0, 0. So how do I find this? I subtract this from 360, and I end up with 323.13 degrees. That's my bearing. The distance SR. So SR, once again, I'm going to redraw it. So this is SR right here. So I'm going to redraw this, and this is what I end up with. And the calculation is very simple. So I have theta, I know 56 degrees. I have the hypotenuse and the adjacent, therefore I must use cosine. So I'm setting it up. Cosine of 56 equal to 8.4 over y. I cross multiply, I get y cosine 56 is 8.4. Divide both sides by cosine 56, and the answer came out to be 15.02 kilometers. This is another bearing question. It says here, this is a scale drawing, by the way. So now it says to calculate the shortest distance in meters from B to D. This is B over here, and this is D over here. So what I did is I drew a line, I measured it, and the line was 12 centimeters. But what is the actual distance? I need this. So the scale is 1 centimeter is equal to 25 meters. So what I did, I set it up as an equal ratio. 1 centimeter is equal to 25 centimeters. So 12 centimeters is equal to, I don't know. I cross multiplied, I get 1x, which is x, is equal to 12 meters times 12, because cm cancels with cm, so I get x equal to 300 meters. Part B. Write down the bearing of D from C. So now what I did, I actually took my protractor and measured this angle in here. And this is 40 degrees, see? I took my protractor, you must know how to measure. So you take my protractor and do it like this, all right? Line up, okay? And it was 40 degrees. So now the bearing of D from C. So C is my starting point, so I draw a north line, I go clockwise, and subtract 40 degrees from 360, I end up with 320 degrees. Now it says here, calculate the bearing of C from D. So D is where I'm going, D is where I'm starting from. If this is 40, these are both co-interior angles. You see that they add up to 180, so this must be 140. So this is my bearing Y, because it is measured from the north line and it's measured clockwise. All right, so that's 140, and it's also a 3-digit number. So the bearing is 140 degrees. D, calculate the length. Okay, a roadway of length 80 meters is to be constructed on the property. Calculate the length of this roadway will be on the scale drawing. So I got to change 80 meters into centimeters. Sorry. Once again, this is the scale factor. 1 centimeter is to 25 meters, as I don't know how much ever centimeters is equal to 80 meters, right? Cross multiplying again, all right? So I get meters cancel with meters, by the way, and I end up with 1 centimeter times 80 is equal to x times 25. I got to move the 25, so divide both sides by 25 and get x equal to 3.2 centimeters. Last one that I'm throwing in here, and this one shows up a whole lot, I'm just throwing it in. They say to enlarge this by a scale factor of 2. So now what I'm going to do is, and you label the image as P1, Q1, R1, S1. So the P, I'm enlarging everything from P. This is the same way that you're going to use on the extended paper. But they also use this on the core paper, but on the extended paper, actually it's the same thing basically. So what I'm going to do is, I'm going to call this point P and P1 because this is my object and my image. Now, from this point, I'm going to draw a line through every point. You see that? And then I'm going to use either a divider. See that? I'm going to use a divider. So this is scale factor 1, this is scale factor 2. See that? Bam. Mark that point. Draw a line from P to every point, and I'm going to do the same thing again and again. And I'm going to stop 1 second, and then I'm going to come back to the drawing. Now this is the object, and this is the enlargement, the image. Notice from here I have everything Q1, R1, S1, but this starting point I have labeled as P and P1. Okay? Be blessed. I will send another video shortly.